Hello and welcome, my name is Amir, and in this video we're continuing our journey into the Codewars website. Let's grab two problems and try to solve them. Let's get those that are not have any issues reported. So maybe this one, and one more, this one, computing the complex logarithm function. Okay, let's go and see what is this one. Okay, this one is prime factor, inspired by one of Uncle Bob's TDD kata. Write a function that generates the factors for a given number. The function takes an integer as a parameter and returns a list of integers. Okay, so for example, for 8, we should return 3 2's because 2 times 2 times 2. Right, that is what I wanted to see. And for 9, 3's, and for 12, 2, 2, and 3. Okay, so to resolve this, I will start, for example, by dividing this number by 2. And if it's divisible by 2, then I would add 2 to the return value. If it's not, I would go to the next number, which is 3, and do the same division until I get to the 12. So let's go and train. Okay, so first is that the factors, which is the thing that we will return, is an empty array in the beginning. Then, as I said, for I from 2 until it is, let's say, less than or equal to n, because it might be a prime number and only divisible by 1 and itself. So we need n here, and then add 1 to the I. So this is for numbers. And when I get 2, I need to divide n by 2 until that number is not divisible. So for example, if I have 12, I will divide it by 2, we will get to 6. Then I will divide it by 2, I get to 3, and then I would jump out. So I need another loop here. I would have it written as a while, and I would say not this, or actually if this, if I can divide n by I, then I need to stay in the while. I would add to the factors the number I, and I would say that n is n divided by I. This line is just like saying n equals n divided by I. This is the short version. And when this while is done, then I would go and add to the I for the next, so 3, 2, 3, and so forth and so on, until I get to the end. And when everything is done, I can return the factors. This looks okay. Let's see, and yep, and attempt here. Awesome, great. So this one is solved. Let's submit and go to the next one. This one, compute the complex algorithm at any given complex number, accurate at least 1 in 10 to the power of negative 12, and the imaginary part should be inside the interval minus pi to the pi. Okay, you shouldn't try to compute the value of this function at the poles. So these two values. Please return one of these or draw an through an error. Okay, so this should be fairly simple. The thing that we need to do, as it says, is like an array of 2 items. First I need to check the bounds as said here at the pose, this part. So I would say if the real part is 0 and the imaginary part also is 0, then return null. Otherwise, I need to return two values. One is the logarithm from the real part times the real part plus the imaginary part times the imaginary part, like this. And I need to get the square root of this value by the Pythagorean theorem, if a squared is b squared plus the c squared. So I need to get the square root of this value, like this. This is the first part, and the second value would be a tan 2 of those two values, image and the real part. So this should be about this puzzle. I wouldn't go into the details for the math and logarithm and so forth and so on. You can go and read about logarithm and arctangent and stuff like that. Yeah, that looks okay. And it's correct. Awesome. So yeah, submit. We are at we're close to rank 5. So in the next video we will continue our journey. Thank you for watching and see you in the next video.